Everyone, in this video you will learn about compound angle identities. Okay, I will copy the formula of compound angle identities from the formula booklet. Okay, in compound angle identities, if you have sine A plus B, then it will be equals to sine A cos B plus cos A sine B. And then sine A minus B equals to sine A cos B minus cos A sine B. So plus is sine cos plus and then minus sine cos minus. And then for cos A plus B equals to cos A cos B minus sine A sine B, and then cos A minus B equals to cos A cos B plus sine A sine B. Okay, and then for tangent A plus B equals to tangent A plus tangent B out of 1 minus tangent A tangent B. And then tangent A minus B equals to tangent A minus tangent B out of 1 plus tan A tan B. Yeah. Let's start to solve some problems. I have question number 1. Okay, show that cos pi per 12 equals to square root of 3 plus 1 over 2 square root of 2. Okay, and answers. Okay, cos pi over 12 equals to cos. Okay, pi over 12, so it's like pi over 12 is 180 over 12 or equals to 15 degrees. Yeah, so we cannot find the cos of 15 degrees using spatial angle, trigonometric of spatial angle, but we know the cos of 60 and also 45. So 60 minus 45 is 15 also. Then I will write 60 minus 45. So because this is pi, I will use pi. This is pi over 3 out of pi over 4. Okay. So 15 degrees equals to cos 60 minus cos 15 degrees equals to cos 60 minus 45, or cos pi over 12 equals to cos pi over 3 minus pi over 4. Okay. Okay, and then after that I will use this rule because this is minus, then cos A cos B plus sin A sin B. So cos A is pi over 3, cos B is pi over 4, plus sine pi over 3, sine pi over 4. So equals to cos pi over 3 is half, right? And then cos pi over 4 is square root of 2 over 2. And then sine pi over 3 is, it's like sine 60 is square root of 3 over 2, and then square root of 2 over 2. Okay, and then multiply square root of 2 over 4 plus square root of 6 over 4. Okay, we can add the square root of 2 plus square root of 6 over 4. Okay, but here is square root of 3 plus 1 and then over 2 square root of 2. Okay, I will check this one. I will move this one over here. Square root of 3 plus 1, 2 square root of 2. I will rationalize the denominator times square root of 2 times square root of 2. Then this is square root of 6 plus square root of 2 over this one, 2 times 2, this is 4. Okay, so yeah, I think this one and this one are equal, so yeah, proven. It's proven. Okay, and then now question number 2. Okay, show that with cos A plus B cos A minus B, it's identical to cos A square minus sine B square. So we will prove this one, and then let's prove answer. Okay, so we will expand this cos A plus B, cos A minus B using this rule. Okay, let's copy this one, bring here. Okay, cos A plus B, so cos A cos B minus sin A sin B. So cos A plus B is cos A plus B. I will rewrite the equation. Cos A minus B. Okay, cos A plus B is cos A cos B minus sin A sin B. Okay, and then times this one is cos A cos B plus sin A sin B. Okay, you know that if we have algebraic form like this one, A minus B times A plus B, the first term and the second terms are equal, then we can multiply as A squared minus B squared, right? So this one cos A square, this one times this one, and then the second term times the second term, so cos A square times cos B square. Okay, minus sin A square sin B square. Okay, then okay, cos A, okay, cos A square, okay, sin cos B sin B. Okay, I will simplify this. I will use another of trigonometric identities. Cos cos x squared equals to 1 minus sin x squared. So cos B squared 1 minus sin B squared. Why I use these identities? Because we will prove this one here, and we need sine b. Okay, so here is cos b, then I will convert this cos become sine, so 1 minus sine b square. Okay, and then this is sine a square sine b square. Okay, and then cos, let's open the bracket, cos a square minus sine b square cos a square minus, I open the bracket, this one time and then this one, yeah, and then sine a square sine b square. Okay, and then next step is, let's simplify this. I have sine here and also sine b here. Okay, I hope I can remove this cos a and sine a. Okay, first I will rewrite this cos a square and then minus sine b and sine b, take out the sine b, and then sine b square cos a square, take out the sine b, and I will write the cos a square here. Okay, because it's negative, so already negative here, so plus, yeah, sine b, negative sine b is already here, and then plus sine a square. We know that this is 1, yeah, equals to 1. So it's equals to cos a square minus sine b square. Okay, check this one. Proven, yeah? Okay. Okay, that's about the compound angle triangles. Next, I will show you about double angle triangle. Oh, I mean double angle identities. Okay, double angle identities. I will copy the formula. This is the formula for double identities. Uh, this one for tangent, I will put in here, and also double angle identities for trigonometry is with this one. For sine and cosine is this one. Yeah. Okay, this is the formula for double angle identities. So sine 2 theta is 2 times sine theta cos theta, and then cos 2 theta is cos theta quadrat minus sine theta quadrat, or equals to 2 times cos theta quadrat or cos theta square minus 1, and then equals to 1 minus 2 sine theta square. Okay, and then for tangent, tan 2 theta equals to 2 tan theta over 1 minus tan theta square. Okay, and let's try to solve some problem using these rules. Number 1, given that sine A equals to 4 over 5, then evaluate sine 2A and cos 4a. Okay, answer. Okay, sine a is 4 over 5. So if I have angle A here, and then this is right angle triangle, so this is 4 and this is 5, because sine is opposite over hypotenuse, then we can find this one. To find the cos, we need the cos A. Cos A is using Pythagorean theorem. This is 4, 5, and this is 3. So cos A is 3 over 5, right? Okay, then to evaluate the sine to A, let's use this one, cos to, sine to theta is 2 sine theta cos theta. So here sine 2A is 2 sine A cos A. Okay, equals to 2 sine A is already given, 4 over 5. And we have found this cos A is 3 over 5. Okay. Then 24 over 25. Okay, so this is the answer from sine 2A. And then next is cos 4A. So cos 4A, the formula is only for 2A or 2 theta. So for cos 4A, I will make it as cos 2 times 2A. Okay, and we already know the cos sine 2A and cos A and sine A. Okay, we can use which one? We can use this one. Yeah, if cos 2 theta equals to 1 minus 2 sine theta, so this is cos 2 theta equals to 1 minus 2 sine theta square. Okay, then if I have cos 4 theta, then I will make it as 1 minus 2 sine 2 theta square. Okay, I already know the value of sine 2 theta here, sine 2a here. Okay, so cos 2a is 1 minus 2 sine 2a square. Okay, 1 minus 2 times sine 2x, we already know this is 24 over 25. 24 over 25 square, or 1 minus 2 times this square is 576 over 625, or 1 minus this is 1152. You can check my calculation. Yeah, okay, and then minus 527 out of 625. So this is the cos A. Okay, this is the example number 1, and I will go to example number 2. Okay, show that sine 3a equals to 3 sine a minus 4 sine a cube. Okay, so and an answer. Okay, there is no rules for sine 3a, only for sine 2 theta. So I will expand this sine 3a becomes sine a plus 3a, like this one. Sorry, a plus 2a. Okay, so I will combine two rules. the rules for double angle identities and for compound angle identities, because for sine A plus B is sine A cos B plus cos A sine B. Okay, so for this one, sine A cos 2A plus cos A sine 2A. Okay, or equals to sine, and then we can expand here using this formula of cos. Okay, we can use this one minus 2 sine theta square. Why I use this one? Because the result here is sine A cube, so maybe we can use this one. Yeah, so I will try using this one, 1 minus 2 sine theta square. Okay, so sine A and 1 minus 2 sine A square. Okay, and then cos A sine 2 theta is 2 sine A sine 2A is 2 sine A cos A. Okay, and then I will open the bracket, sine A minus 2 sine A cube, because this is sine A square times sine A, so sine A cube, plus I will multiply this one, 2 sine A cos A square. Okay, and then now for this one, what will you do? Okay, this is cos here. There's no cosine in this form, so I will make it as sine. So sine A minus 2 sine A cube plus 2 sine A and 1 minus sine A square. So I make it as sine A square because there is no cosine here. Okay, we will prove and make it this form like this one. So I will remove the cos. Okay, I mean convert the cos to sine itu ya. And then sine A, okay, sine A will rewrite sine A minus 2 sine A cube plus 2 sine A minus sine A cube. I mean 2 sine A cube. Okay. Okay, now we can simplify this. I have sine A and then 2 sine A, so the total is 3 sine A. And then this one I have 2 sine A cube and then minus 2 sine A cube, and then total is minus 4 sine A cube. And then let's check. This is 3 sine A and then 4 sine A. Yeah. Okay, and then proven. Okay, that's all about compound angle identities and double angle identities. I will give you slides maybe after this presentation. You can check the next activity. Maybe there will be some questions in the slide about compound and double angle identities. Okay, thank you.